here's your answer to number 6 quickly. If you want to write that down, write it down, and then go back and do the work to see if you can get it. But that's one we skipped. It's adding, subtracting on the same work, but multiplication, really, remember if you can cross things off on the top and the bottom, it'll make your life easier. So 15, you might do what's called prime factorization or something. There are different ways people handle this. 15 can be written as 3 times 5. What's a way to write 21? Times 3 times 7. What's a way to write 28? 4 times 7. If you're really doing a prime factorization, you'd make 4, 2 times 2. What about 25? 5 times 5. So, you have a bunch of numbers on top being multiplied, a bunch of things on the bottom being multiplied. What can we do? I can get rid of the 7. Because what's 7 divided by 7? 1. And what's 1 times everything else in the problem? 1. Everything else in the problem. There's a 5 on top, and there's one of the 5s on the bottom. So what are we left with?
3, 4, 5.
3 times 3?
9.
4 times 5? 20. That's a nice reduced fraction. When you're back in 3rd or 4th grade, whenever you learned how to do your fractions, some people did it this way. Oh, 15 and 25 are divisible by 5, and you might have gone 3 and 5. 28 and 21 are both divisible by 7. 28 divided by 7 is 4. 21 divided, you might have just crossed them off and written things right on the problem, then multiplied across the top, multiply across the bottom. When you multiply fractions, across the top, across the bottom. So we can do the exact same thing. I'm going to skip 9. We're going to go right to the more difficult one, 10. You can do 9. I can put the answer up and you can do 9 on your own. But again, what we're really testing you on is your factoring. So if you're not very good at factoring, it's going to be more difficult. But the left-hand side is already done. There are no factoring, or no factoring to be done. There aren't, it's done, whatever. This one is x minus 3, x plus 1. The denominator here would factor into x plus 2, x plus 1. So now you have a bunch of stuff being multiplied across the top, a bunch of stuff being multiplied across the bottom. So with multiplication, once you've done all the factoring, it's things that are being multiplied together, so we can just get ready to cross off. Is there an x plus 2 on the bottom that we can cross off? Yeah. So let's get rid of that. Is there an x minus 3 on the bottom? Yeah. Is there an x plus 1 on the bottom? Now, when you cross things off, we tend to be a little bit lazy when we do that, but when you cross it off, you should really be writing, the 1s. So it's not that you're getting rid of it, you're leaving behind a 1, because what's x minus 3 divided by x minus 3? 1. X minus 3 divided by x minus 3? 1. So what happens is you have a bunch of 1s, and so the final answer turned out to be 1. So you're going to work on number 9. Do some factoring. I'll put the answer up there in about 10 seconds. So there'd be your answer to number 9. So listen. The 4x squared factors into the x, 4x minus 1. If you want to, the 14 you can split up into 2 times 7 times x. The 4x cubed you can split into 2 times 2 times x times x times x. And the 8x and the 2 can split up into 2, 4x minus 1. So literally, I have broken it down into the simplest parts, and then you can look for things to cross off. So there was an x here, I can get rid of one down there. There's an x here, I can get rid of that one there. That's what was happening. There's a 4x minus 1 factor, there's a 4x minus 1 factor. There was a 2 there, maybe I took that 2, it doesn't matter which one you cross off. So at the very end, the only thing that's left is the 7 on top and the 4x on the bottom. Now, when you do your factoring, like Noah worked on this one, he did not, like the 4x cubed, he did not break it up into 2 times 2 times x times x times x. He would just cross off that x on top, cross off the x cubed on the bottom, and write x squared. He just kept knocking those down one level. So you don't have to do all the pieces at the beginning and then cross them off. You can kind of do what we did earlier. Any questions? Dividing rational expressions. Dividing. The nice thing about dividing is it's really the same thing as multiplication. So, when you divide by a fraction, what do? You multiply by the reciprocal. So in this first one, I have 2x plus y over a. Instead of dividing, and you have to be careful because that kind of looks like a plus sign, but it's the division. We're multiplying by a squared over 3x plus y. What did I do? Instead of dividing, I'm multiplying by the reciprocal, which just means flip that second fraction. So what can we cross off? Well, there's an x plus y, there's an x plus y. There's 1a down here, so when I cross this one off, we have to remember to write the a. I only cross off 1 from the bottom, so when there are 2 on top, there's still an a. Anything else? No. 2a over 3. To finish 12, 13, and 14, I'm not going to do all the work because it's really the same. So I'm going to pause the video. What I want you guys to do first, the first step, I want you to take 12, 13, and 14 and just don't do the factoring, just do the setup of multiplying by the reciprocal. What would it look like when we go to multiply by the reciprocal? So just change that down. What will it look like when you multiply by the reciprocal? So that's what I'm talking about in 12, 13, and 14. So if I give it to you in what's called a complex fraction, like in number 14, it's the fraction on top of a fraction. You have to understand that the bottom 2 are the bottom fractions, so that's the one you flip. 13, dividing by the fraction when they put them next to each other. It's a little bit easier to see which one you're flipping, but in either case, this is what it's going to look like. So the next step is to go through and factor these things. So I'm going to go to 14, and I'm going to work on 14 with you. I'm going to skip 12 and 13 to let you guys work on them, and then we'll put the answers up again. So when you go to 14, I would just do the factoring right above them and below them. X squared minus 1 is a difference of squares. That will factor into x minus 1, x plus 1. X squared plus 5x plus 6. That will factor into x plus 2, x plus 3. The right-hand side, or the fraction on the right, factors into nothing on the top, but the bottom is x minus 2, x minus 1. So we are really going to test how well you guys know your factoring from the chapter 7 we just got out of. So now slowly work your way through. I just start on the top. x minus 1. Is there an x minus 1 on the bottom? Yes, it's over here in the red. Is there an x plus 1? No. Is there an x plus 3?
Yes.
Yep, so that purple one and that blue one. There's nothing else in common. So a good final answer would be x plus 1 all over x plus 2, x minus 2. So again, I'm going to pause. 12 and 13 you're going to do on your own. And then I'll put the answer up there. If you have questions, let me know. Alright, so there are the answers to 12 and 13. As you get better at this, you'll be able to take the quadratics on this right hand side and flip them. And then just start crossing things off. So x minus 1 over 2. Over here again, we've broken it down into 2 times 2 times x times x times x. For some of you, that visual of breaking it down into its smallest factors will be easier for you to see what's going on when you're crossing things off.